Good morning, friends. In my last video, I explained you the substitution reactions of the benzene ring. Now today I will explain you directive influence of the substance in the benzene ring. What do you mean by the directive influence of the substance? You see, in the case of the benzene, of the six positions, that is hydrogen atom, of the six positions, they are equivalent in nature and they form the mono substance. Now here point is that when this mono substance benzene ring further substituted, listen, when this mono substitute benzene ring undergo further substitution, then what will the position of the incoming substance? This is a very important thing, and this depends upon the nature of the substance which is already present in the benzene ring. Now, there are three positions in the case of the benzene ring: first, second, and the third. First is known as the ortho, second is known as the meta, and third is known as the para positions. Now, whenever second substitution takes place, influence of the substrate already present in the benzene ring, it may influence on the ortho position, or to the meta position, or to the para positions. So we say ability of the group present in the ring influence the incoming group to a particular position, that is, it may be at ortho, meta, and the para position. And second influence is that either it activates the benzene ring or it deactivates the benzene ring. So this is the influence of the substance group present in the benzene ring for the next substitution. Now you know, in the case of the benzene ring, substitution is electrophilic in nature. It means groups which are present in the benzene ring, they either increase the density of the benzene ring by the electrons. So we say that there are two types of the groups: one which release the electrons and increase the density of the electron in the ring, and second, electron withdrawing, that is, they withdraw the electron from the benzene rings and decrease the density of the electron in the ring. These are known as the deactivating groups, and the electron releasing group, they are known as the activating groups. Now I will explain you few examples in the case of the arc and para directing, and arc and para directing, that is deactivating, and here arc and para directing, that is activating in nature. Now in the case of the arc and para directing activating groups, that is, for example, phenolic, peroxy, methyl, and others groups which release the electron to the benzene ring. If we take example of the phenol, when undergo nitration, it forms the orthonitro and the paranitro phenols. Now what is the mechanism behind this? See, this OH group releases the electron, and if we see the resonance structure of the benzene, this electron, one pair of the electron from O goes to the ortho position and increase the density of the electrons, and in second position the electron density increases at the para position. So from the resonance structure it is clear that the ortho and the para positions, they are having more density of the electrons as compared to the meta position. So these groups, they are the ortho and the para orientation. Now this is the activating group. Now the most important thing that in the case of the ortho and the para directing, there are certain groups which are deactivating in nature and they withdraw the electrons. Point is, they are ortho and the para directing, but they are withdrawing property of the electrons. Listen here. If we take the examples of the halogen, fluoro, chloro, bromo and the iodine, and you know, it has a very good property of the negative inductive effect. No? This is negative inductive effect. Now this chlorobenzene when undergo nitration, it forms the ortho and the para positions. Now here if you see the resonance structure, see it is inductive effect. Negative inductive effect means it releases the electron, though it is a withdrawing in nature. But again if you see that the position of the ortho and the para, they are having more density of the electron as compared to the meta, that is the resonance structure. So density of the electron decrease in all density of the electron decrease, but at ortho and para position density of the electron is more as compared to the meta position. So this is the very important thing, that though the fluoro, chloro, bromo, iodine, they are ortho and para directing group, but they are deactivating nature and they withdraw the electron, but due to the negative inductive effect, it forms the ortho and the para positions. So I think it is clear to you. Ortho and the para directing, ortho and para directing, that is deactivating and the activating. Now in my next video I will explain you the meta directing groups and some more directing influencing groups. I think it is clear too, and it's very important thing for the organic chemistry. So if you like my video, please share and subscribe. Thanks very much.